Okay, so now we're going to take a look at some more real-world problem solving with two-dimensional motion, and be able to go beyond just the simple over-the-ground projectile motion type problems that we've done, and move into some more advanced type of situations that we can solve, which are pretty cool here. So here's the first one. Let's say we have a ball, and this ball is kicked with an initial velocity 45 meters per second at 40 degrees. Question I want you to find is, will it make it over a 40-meter wall? So what you're going to need to do is set this up just like you did before, getting your x and y values, and determine if it's going to clear the wall. So go ahead and pause the clip, do your best, go as far as you can, and then you can continue when you're ready. Okay, so we get our x velocity 34.5 and then y velocity 28.9. And in this case, when we look at the time, we can get the time halfway, which would be 2.59 or 2.952 seconds. That's the time halfway. And with that, we can figure out, how far it goes, as well as, and actually in this case, we really, the only equation that we actually needed is the middle one, which is the height right here, because we know the final velocity at the top is 0, the initial velocity is 28.925, the acceleration is negative 9.8, and so this is how high it will be in the very middle, 42.7 meters, and that's good. So this is the actual only portion that we would need for this to know if it clears it. So what we're going to do now is at 37 meters, how high is the projectile? So in this case, we want to know, 37 meters from the original position, how high is it in the x, or how high is it in the y? So when we look at our x problem, we can figure out, what we need here. The we have the y velocity, or the initial y velocity. What we really need to know is at what time period is the ball at 37 meters in the x. So when we do that, we know the displacement, what we need in the x is 37. We know the initial x velocity. So it turns out after 1.073 seconds, it is 37 meters from the original position, which is right here. And then with that time, we can place that in into here and here, and then determine what height it will be. What's the final height of the ball? So when we do that, we can determine that the height is only 25.395 meters, so that would be maybe somewhere around here, and it's only going to be that, that high at that point before going up to the top. Okay. So let's take a look at this situation. Let's say we have a serve, and this tennis ball is being hit perfectly horizontal, and the height of the ball is 3.2 meters. The distance from the line to the net is 11.89 meters, and so the question is, what would be the minimum velocity required for the ball to clear the net? And again, we'll assume that Vy initial is 0 because it's all just in the x velocity starting out. So you're going to look at the x problem, y problem. Why don't you pause the clip and see if you can determine the initial x velocity required. Okay, so to know what's going on in the x, we know the displacement is 11.89, and we need to know how fast the velocity needs to be. But the question is, how much time do we have to clear the net as well? And so that's really going to be the issue in the y. How much time until it falls to the height of the net? And so our initial y position, we know is 3.2. The final y position, it's a 1 meter tall net. So it's only going to have 0.67 seconds to clear the net. So when we place that in there, we can determine that the minimum, absolute minimum velocity to clear the net, or really to get right there, would be 17.74 meters per second minimum. Anything more than that will clear the net. Okay, so let's go ahead and try this one. Let's say we have a tennis ball that's hit at an angle of 30 degrees with a speed of 19 meters per second. The question is, will this ball clear the net? The initial height of the ball is 0.3 meters. Then the distance, or the displacement from the ball to the net is 11.89 meters. So go ahead and pause the clip and work out the x and y and see if you can figure out if this ball will clear the net or not. Okay, so this is a key question. In other words, what is the height at displacement 11.98 meters? We are going to break up the velocity in the x and y. So the initial x velocity 16. I can't remember if that was 4.5 or 9.5, and then 9.5 meters per second. We know the so 16.45 is the initial x velocity, and we have delta x, and so at what time period will it reach the net? It's going to be, the time period would be 0.723 seconds. So with that, we can bring that into the y and figure out how high it will be at that spot. So we know that the initial y height is 3, and then the final height is what we're looking for. And we know the initial y velocity is 9.5, and we have the time, and so it'll turn out to be plenty high. The final height at that time period would be 4.607 meters, and so it's going to clear it by 3.6 meters. Not a problem.